Hello children, welcome to your physics class. In the previous lecture, I discussed about resistance, resistivity, conductance, conductivity qualitatively. I also discussed about the SI units of all these physical quantities. And in this lecture, means today's lecture, I am going to discuss about factors affecting resistance. I will also discuss about the grouping, combination of resistors. Okay, so let us start with factors affecting resistance. You know, resistance R is equal to rho L by A. Got it? Here rho is the resistivity, L is the length of the conductor, and A is area of cross section of the conductor. So on the basis of this formula, you can understand that this resistance R depends upon rho, depends upon L, and depends upon A. Okay. So first factor which affects resistance is called length of the conductor. This is length of the conductor. Means if you will increase the length of a conductor, its resistance will increase. Okay, if you will decrease the length of the conductor, its resistance will decrease. That is, you can write R is directly proportional to L. Second factor which affects resistance is area of cross section. Area of cross section of the conductor. Okay, area of cross section of the conductor. From this equation, you can observe that area of cross section A and R are related as R is inversely proportional to A. That is, R is inversely proportional to A. What does it mean? It means if you will increase the area of cross section of a conductor, its resistance will decrease. If you will decrease the area of cross section of the conductor, its resistance will increase. Got it? So R is inversely proportional to A. How has it been related to A like this? It was discussed in the earlier lectures. Okay. So R is inversely proportional to A. Third is nature of the material of the conductor. Nature of the material of the conductor. Means it also depends upon the nature of the material of the conductor. You see, this rho is resistivity. It is based on the nature of material of the conductor. Means if you use a wire of length 1 meter and 1 millimeter square cross sectional area made of copper, and you are using a wire, another wire of length 1 meter and 1 millimeter square cross sectional area with the aluminium. Okay, means one is copper wire, other is aluminium wire. Then both the wires will have different resistances, although they are dimensionally same. Their length and their area of cross sections are equal. Then why has it been changed? So the resistance has been changed due to change in the material of the conductor. Got it? Okay, so it depends upon the nature of material of the conductor. Third one is this. Now I am going to discuss about the fourth one, temperature. Temperature of the conductor. Means if temperature will change, the resistance will change. This is related with a formula. The derivation of that formula is not relevant here. I will not discuss the derivation of the formula. I am just going to explain the dependence of resistance on temperature with the help of formula. Okay. So suppose this is R2. This is R1. So R1 is the resistance at temperature theta 1 degree Celsius. Okay. R1 is the resistance at temperature theta 1 degree Celsius. Now the temperature of the conductor is increased to theta 2 degree Celsius. Then resistance has been changed to R2. and these are related as R2 is equal to R1 1 plus alpha theta 2 minus theta 1. Got it? Means R2 is equal to R1 1 plus alpha theta 2 minus theta 1. Here R1 is resistance at temperature theta 1. R2 is resistance at temperature theta 2. Resistance at temperature theta 2. This can be in Kelvin or this can be in degree Celsius, but if you will want to calculate the value, you must change into Kelvin because we are using SI unit of resistance, so temperature should also be in SI unit. Okay, so this is resistance at temperature theta 2, and from this formula R2 is equal to R1 1 plus alpha theta 2 minus theta 1, you can write alpha is equal to R2 minus R1, R2 minus R1 by R1 theta 2 minus theta 1. Okay, this is a constant for the given material of the conductor, and this is called temperature coefficient. Temperature coefficient of resistance. Temperature coefficient of resistance. Got it? So from here you can understand that if theta 2 is greater than theta 1, alpha is positive. So the resistance increases with increase in temperature. But if you will be talking about a semiconductor,